All right, let's try a different kind of problem, but you can see that so you can see the variety of things that we've got going here. So here we go. We've got two poles. You can see them. One's 10 foot tall, one's 20 foot tall, and we have to connect a wire to them. And for some reason, it's got to make this little. It's got to be anchored to the ground right here. And of course, now you can do it like this, right? You could anchor it like that, or over in that area, or over in that area. But the interesting thing is, wherever you anchor it, you're going to have, it's going to require a different amount of wire. So we want to find the one point that minimizes the amount of wire needed. Okay, so that's where we start with the problem. What is it we need to minimize? The length of the wire. Okay, so let's just do this. Let's just say, okay, if that length there from the little pole to the anchor point is A, and that length from the big pole to the anchor point is B, then we know that the total wire, as is here, the distance of 30 feet between the two poles is set, but we don't know what those two lengths are going to be. We would like to minimize A plus B is what we want to do. Okay. Um, and those are dependent on the distance x that where we put the anchor point. So we're going to be using a little trig here because we can come up with some equations for a, for instance, right? So we know that a is equal to, or well, we can do it a number of different ways. Probably the easiest way is maybe actually use the Pythagorean theorem. We know that this is the case. We'll write it up here. A squared equals 10 squared plus x squared, right? Pythagorean theorem. So A equals 100 plus x squared. Likewise, B is going to equal, well, it'll be 400 plus 30 minus x squared, right? 400 is 20 squared. We need some square root too. So A is that, B is that. And so the total distance that we have to cover is A plus B. So the distance, or let's call it the length, because that's what we're trying to minimize here. The length of the wire, depending on the anchor point, is the square root of 100 plus x squared plus the square root of 400 plus 30 minus x squared. Let's go ahead and work that out so that it'll be a little easier to work on. There it is. There's 30 minus x squared. So that's, of course, 1,300, and we'll convert that as we go. But there's our equation, and we want to find the extrema for that equation. So just like always, we're going to take the derivative. It's going to require a couple chain rules. So the derivative of this first piece looks like this. Oops, let's try that. So minus 1/2 power times 2x, right? Chain rule. The derivative of the second piece is 1/2. 1,300 minus 60x plus 2x. No, plus x squared. Minus 1/2 times the derivative of the inside, which is a negative 60 plus 2x. And there's our derivative. Certainly not an easy derivative to work with. Let me simplify it here just for a moment. And so we get to this point, and of course we're trying to figure out when this equals 0. When does the derivative equal 0? Now this is a little more complicated. All right, so we've jumped ahead a little through the algebra here. Let me just talk about it briefly. So what we did was, in order to solve this equation equal to 0, right? Set it equal to 0 and find out where the derivative equals 0. First thing you do is you multiply through by both of the denominators, so all the fractions disappear. And then this little part right here, I've moved this to the other side, and that changes your signs right in that term. Then you square both sides to get rid of the square roots, and that leads you to this point right there. After that, you're just foiling everything out, carefully keeping track of everything until you get down to this point right here. Divide by 300 gives you this simple quadratic, which can be factored. And so you have two solutions, negative 30 and 10. And so since, remember, x is the distance from the little pole, the negative 30 makes no sense. So it's just x equals 10. So if we go back up here, we see that if we let x equals 10, then of course, whoops, let's switch that. If we let x equals 10, then that of course makes this 20, and that will minimize a plus b. That will let you use the least amount of wire to form this anchoring. And if you look closely, basically what you formed is two 45, 45, 90 triangles, and that kind of makes some sense. So you can see similar kind of problem. Find the function, take the derivative, find the zeros, find the minimums.